is the input of the motor, and the analog input of the quantum is the output of the motor. So we can get the signal from the motor to the computer. Now I'm going to show you the configuration that after you build the Simulink that you have to do for this lab. Now if you see, I have the tachometer in channel 3. This one is going to be S4 for the power module. It's gonna be, I have 3 and S4 is gonna be 3 because you count S0, S2, S1, S2, S3 and keep going. I have channel 3 is gonna be S4, and right here you don't have to do anything for the analog output. It's gonna be always channel 0 right here. An important thing right now, I'm going to show you this part, the constant, because I wanna stop the simulation in a specific time. I use 4 divided by the frequency. This constant, I use this constant in my code, so I'm gonna explain you later why we use I use this constant core frequency. I think that's it. Oh, sine wave. Oh, okay. And the sine wave is gonna be the amplitude. The configuration of the sine wave is gonna be the amplitude that you have in your code, and the frequency is gonna be the frequency times 2 pi. So why we do that?
Because our frequency in the code is in hertz, but MATLAB wants it always in radians per second. That's why.
Okay. And I think it's okay.
So now he's just going to build the
build
model.
the model.
Yeah.
So we build in. Yeah, it's running.
Can you show them the button that you hit again? The button that you hit for the build.
Okay, to build this simulation, you go really quick. You go to increase build, so you click on it and just wait, and it's gonna tell you if the simulation is good or not.
Just a note about this, when you build it for the first time, it will take a really long time to build, and that it should be no surprise. Also, if you are running your code from your jump drive or anything, it is a good idea to not do that, because that will increase the time by at least 15 times.
Yep.
So never run it off your jump drive.
Yeah, and remember, if you are using constant from your code, you first have to run the code and then build the simulation.
Yeah, because if you have constants in your code that you use in your Simulink model, then the constants initially are not in the workspace where it is picked up from for compilation purposes. So you can enter any dummy variables in the MATLAB command window or run those lines of code so that they are in the workspace.
Yep. So right now I'm going to show you the simulation, how to get the data from the motor. Now let me run it again. After that, after you build the simulation, Simulink is gonna show you this window, so you can be able to run the program. First of all, because you have an output, you go to this link. This is the scope. You click on it and then select the output and open it. After that, you have to make sure, because if you need to take all of the data, when you're running the code that you have to use, it's gonna take the data that you are seeing from the scope. So you have to modify the buffer at least in 10 seconds. This is gonna be the X, and also you have to increase the size of the
yeah, y-axis.
y-axis.
It's in the axis fixed range. Yeah.
Yep. So you put in like 5 or
Yeah, 5 minus 5 is okay.
5 and minus 5. Yep. So now you're you're ready to run the program. This is the code that you need to use for this lab. This is the main code. So the first line has the frequency, an array frequency that we're going to use for this lab. It has 15 frequencies. And the second line, this is the amplitude for the motor. The amplitude for the waveform that we're using is gonna have 3 values: 0.2, 2 volts, and 4 volts.
Okay, so as my friend Amin told you here that we have this frequency vector is the frequency in hertz for all the sine waves that we are going to run through the motor, and we do it for 3 different amplitudes at 3 different voltages. So the idea is, the reason we write the code is because if you do not write this code, then you have to open this scope in WinCon, hit the start button, run it for some time, and stop, save the data manually, and do it all over again. Now doing it 45 times would be a big pain, so an easier way is just to automate the whole process and write some code for it. So we have 2 for loops, one for the amplitude and one for the frequency, and so we pick out a frequency each time we're in the loop, and then this command wc_start with your model name. Your model name is the string that is the name of your Simulink model. Note that you do not have to give the .mdl extension. If you do that, it will start, WinCon will start sending your sine wave signal to your motor. Basically it is running your Simulink model and gathering hardware in the loop data. Now the next 3 lines, while WinCon is running lab0 pause 1 and then save the data